you need? You need yesterday's notes. You need your formula sheet. You need 4 different colored markers. We're not making swords out of them. What? Oh. Does anybody else see yesterday need notes? Okay. What? Oh. You want some people? We're going to do some color coding, so I'll tell you when to switch colors. So let's start with your first color. Whatever color you choose.
I choose dusty green.
Okay, we're going to draw an angle. We're going to draw an angle that's in the first quadrant. Huh? First color. Everything in the first quadrant is going to be one color. Okay, let's label this little angle here theta. Okay, now if I have an angle that's in the first quadrant, I can make a right triangle out of it by dropping down to the x-axis. When we made our interactive unit circles with all the little triangles, the triangles in the first quadrant, there were 3 of them that we had, 30, the 45, and the 60. So we knew the distance, right, up to this point, x, y. We also, back when we first started this unit, we talked about how x is the same value as cosine and y is the same value as sine. And both of these values are positive because we have to go to the right and then up to get to that point. So x and y are both positive. Which means tangent would also be positive because tangent is sine over cosine. So if you divide a positive by a positive, we get a positive. So I'm going to put a big A here. A stands for all. All of the terms, all of the trig functions are positive in the first quadrant. Okay, let's take our second color. Okay, this time we're going to draw an angle that ends up being in the second quadrant. So we're going to start on our initial side. Going to go all the way to the second quadrant. That angle is still theta. Now, when I have an angle like this is obtuse. I cannot create a right triangle using an obtuse angle. It's impossible. So instead, what we do is we use this point here, which we know it's in the second quadrant somewhere. And I use that point to create a right triangle. So when we did that interactive unit circle, we had the triangles that were in the second quadrant. Instead of using theta, though, I'm going to use this little angle right here. This little angle is called alpha. Alpha is the little fish. Okay, so alpha, because alpha is not our actual angle, we just use it kind of as a placeholder because alpha is in the same location to get to this spot right here as theta. Alpha is called a reference angle. It's just used as a reference, as a placeholder, so that we can solve the right triangle. Now, if I want the measure of alpha, let's say theta is 100 degrees. What would alpha be? So if this was 100, what would this little angle be? 80, right? Because they're on a straight line. Remember geometry? There's supplementary angles. So the formula to get alpha would be 180 minus theta. Now in the second quadrant, because we have to go left and then up, that point would be negative and then positive. Tangent would also be negative because I'd have to divide a positive by a negative. So the only thing positive in the second quadrant is sine. So put a big S in the second quadrant. Okay, third color. Okay, this time we're going to make an angle that goes all the way to the third quadrant. That's why we're color coding today, because it would look really crazy if we use one color the whole time. It would be hard to tell what goes with what. No. Okay, so if this is theta, and we want to make our little right triangle here, I'm going to drop back to the x-axis. That means this little angle here is alpha. So let's say I gave you 200 degrees was my angle. What would that distance back to the x-axis be? Again, what would it be? This is 200. So this whole thing is 200. What would this little distance be? Of 20. 20, yeah. Because the full line is 180, right? And then 200. That means that's just 20 right there. So the formula for alpha here is your angle minus 180. In the third quadrant, to get to that point, we go left and then down. So both sine and cosine are negative, but tangent would be what? Positive, because you're dividing into a negative. So I'm going to put a big T there for tangent. Tangent, lowercase. I'm just moving T for, I'll tell you in a minute when I make them capital. So you're right. Okay, last color. I'm gonna go with orange. Oh. It's like a winky face then. Okay, last angle goes all the way to the fourth quadrant. Why do you guys pick yellow? Why do so many people pick yellow as a color? Can't see it though. Okay, so if this is theta, we got to make our little right triangle here. It means this angle is alpha. So the formula for the fourth quadrant would be 360 minus theta. So 300 is in the fourth quadrant. What would be the reference angle for 300 degrees? 60, right? Yeah. So all the way to the end would be 60. Okay, now for this point, we go to the right and then down. So cosine is the only thing that's positive in the fourth quadrant. So you might get questions that reference like, what quadrant are you in when sine is positive and tangent is negative? Second quadrant, yes. So how I remember it is A, if you go like to label the coordinate plane, ASTC. My math teacher back in the day, a long, long time ago, taught us all students take calculus. So if you just remember that phrase, you'll remember what functions are positive in which quadrant. So they're all positive, then just sine, then just tangent, then just cosine. Okay, so we should have a beautiful diagram now. Let's go to our formula sheet next. So let's add those to it. Wait, okay. Okay, formula sheets. Let's go to the bottom where it says reference angles. We're almost to the bottom. Draw yourself a grid. We're not going to recreate that whole grid. We're just going to put the formulas on here. Just like that. Okay, first quadrant. Alpha is the same as theta. You don't have to do anything. They're fine. You can make a right triangle from any angle between 0 and 90. The second quadrant, alpha equals 180 minus theta. Third quadrant, alpha is theta minus 180. It's the book. And a mystery house. Yep. So the class is advanced algebra trig, right? So I normally would teach trig up first, but Mr. House with physics asked if I would teach switch around into trig first. That's why we start chapter 5 first. We'll go back and do the other chapters and it's free. Who's in physics from here? You guys use trig yet in physics? Not yet.
I've been doing the same thing since like
No trig yet. I've been doing trig, trying to get it in. You haven't used it yet. Okay. Okay. Let's also put on here ASTC. All students take calculus. I'm sure there's other mnemonic devices. That's the one I learned. I'm sure you can Google other ones, but.
Teachers, please excuse the interruption. Victoria White, please report to the front office. Victoria White, please report to the front office. Thank you.
Okay. So I pass out the, oh, you guys have the notes from yesterday. Pull those out.
So we put on one.
So we have a class. They're not bothering you. Okay, we're gonna skip down to the last three here, 4, 5, and 6. Because we actually already did that middle part. We did the graph, like where it says reference angle, and then there's all that space. That was the big paper we just did. So we're gonna skip down to the last three. Then we'll go up. We're gonna skip all over the place today. Then we're gonna go up to the top. Okay, so we're gonna find some reference angles. So first thing I gotta do is figure out what quadrant it's in. What quadrant is 300 in? 4. Okay, you have your formula sheet. In the fourth quadrant, how do we figure out the reference angle? 360 minus our angle. 360 minus 300 is 60. Your angle should be between 0 and 90. If it's bigger than that, that means it's not in a right triangle. So you use the wrong formula. Now, sometimes your angle might be in radians. So 2.3 is in radians. What quadrant is 2.3 in? Think about it. If you're in radians, here we have pi over 2 at the top. Pi, 3 pi over 2, 0 and 2 pi. Pi we know is 3.14, right? What would be pi over 2 about? 1.57? So where would 2.3 end up being? In the second quadrant here. Between 1.5 and 3.14. So what's your formula for the second quadrant? 180 minus theta. Now we're not going to use 180 because we're in radians. What's 180 in radians? Pi. So pi minus theta, which is 2.3. We have our calculator to do that for us. That we can't do in our head. .842. So radians, you're going to do the same thing. You got to figure out what quadrant you're in, and once you figure that out, just pick the right formula. How about number 6? What quadrant is negative 135 in? Going backwards, right? So we're here. We want this distance. Yeah, 45. Yeah, how'd you get that? Yeah. Now, I know that's the formula for the second quadrant. Why does the formula for the second quadrant work for that angle? Because you're going backwards. So if this is in the third quadrant, I would be using, if I went the other direction, I'd be using the second quadrant's formula. Okay, let's go back to number, actually, let's do a homework problem instead, because I'll make that a little easier. I'm gonna pass out the homework. Yeah, you haven't had homework in a while. It's been a long time.
Just a little bit.
No, I've had like one homework assignment.
That was the golden age.
Golden age, no homework. Now we're ready. We've done enough trig problems. Well, we're ready for homework now. Carrying for it this whole time. We've memorized things. We took lots of quizzes. Now we're ready for the homework. Okay, we're gonna do the first problem together because that will be, then you can solve the rest. The last 4 questions are asking for the reference angle, which is what we just did. So figure out what quadrant you're in, find the reference angle. We're gonna do number 1 together. Number 1 says, show that the point is on the unit circle. We have done this before in different ways. So they're saying, show that this point is on the unit circle. What do we know about the unit circle? It's a circle, yeah. It's round, yeah. What makes it a unit circle and not just a circle? The radius is 1. That's the important part about the unit circle. Okay. What quadrant is this point in? 4th, yep. So we're in the 4th quadrant. Let's say somewhere down there. So I'm going to build a triangle with what I know. And if we're in the unit circle, this should be 1, right? Do we know the other 2 sides? We know the x and the y, right? We know y is -4/5. And we know the x is 3/5 because that's the coordinate of our point. Now, how would we prove that that's true? So on the unit circle, the hypotenuse should be 1. How do we prove that? We're going to do Pythagorean theorem. Oh, I can hear now. So let's see if this is true. If this is true, that should equal 1. So I'm going to take 3/5, square it, -4/5, square it, and that should equal 1 squared. What's 3/5 squared? Yeah, you don't need a calculator for that. Don't use your calculator. What's 3/5 squared? Yeah, you just square the top, you square the bottom. 9/25. Oh my goodness. Oh. Okay, so what's 4/5 squared? 16/25. Okay, 9 plus 16 is 25/25. Is that 1? Yes. So we just proved that's a proof. We proved that one side equals the other side. We just proved that that is a point on the unit circle. If I got something that other than 1, then it can't be a point on the unit circle. So 2 is similar. 3, you're just going to work backwards. So they tell you what quadrant you're in, and they give you the y value. It tells you it's on the unit circle, so you know the hypotenuse is 1. You got to figure out what x is. So you just build yourself a right triangle, label the 2 sides that you know, and then use the Pythagorean theorem. Are you looking at me like that? Okay. 4 and 5 is asking for the coordinate points of the terminal side. So just figure out where it is on the unit circle. What's looking at me funny? Because do I just need to we just go 4, 5, 8, 9 from now on? Let's just skip those numbers altogether. 4 and 5, you're gonna tell me the coordinate points, so figure out where it is on the unit circle. So if it's at pi/2, the coordinate points are 0, 1. And then 6 through 9 are just like what we did today. You're gonna find the reference angle. So I would suggest drawing yourself a little map. You can do all of this in this point, but it's not due until Tuesday. Funny. It's because oh, can't really? Give me a whole list of numbers I can't use.
Something to pass it for. 41.